Hi everyone, I'm Divya from Team Schedulers Data Defenders working on the project called Fileless Malware Analysis. Problem statement of a project is we need to build a web application which can detect fileless malware as all the traditional antivirus softwares cannot detect fileless malware. So we need to find a solution to it. Fileless malware is nothing but a malicious software that runs in the memory because it doesn't leave any traces on the disk and it doesn't rely on the file. So, which makes it challenging for us to identify. So, actually, fileless malware uses legitimate tools like Windows PowerShell to attack a machine. So, this is the process of how attackers attack using fileless malware. First, they need to inject a payload into a machine. This can be done in many ways like phishing email with malicious website links, JavaScript code with hidden malicious code in it. Like after a payload is injected, like it searches for the vulnerabilities in our machine. Windows PowerShell is the most vulnerable tool which can be attacked very easily. Once attacker loads payload into a machine and get access to the Windows PowerShell, they they execute codes and take all the users data. This is how attackers attack. The main objective of the attackers is to get access to the terminal. So this is how it is done. Our approach as fileless malware rely run on the memory, so we thought of doing memory analysis which can by which we can tell whether this file is malware or not. So our approach is ram dump analysis. So this is the process flow that we thought of implementing. Our web application To our web application you can give two inputs, memory dump and a malicious sample. When you give any sample like phishing mail or a website link or anything, it gets executed in the EC2 instance Windows. We've chosen Windows because it's more vulnerable. And after executing, we take the memory dump of the machine, like of the EC Windows machine, and analyze. Like if you give the memory dump directly, we'll take that to analyzing step. Here we are using volatility to analyze the memory dump and extract features. On the other hand, we've actually found a data set which suits with our project, and we've trained it with random forest algorithm, and the extracted features are sent into the trained model for prediction. This is the dataset that I've chosen. It has around 58,000 samples, and the last column tells whether the sample is benign or malware. And it has 55 attributes, and each of the attributes there's a plugin in volatility. So I've chosen this dataset. Uh, Choosing the best ML algorithm among all classifier algorithms. Random forest gave highest accuracy to my dataset, so I've chosen random forest to be my ML algorithm. So here I've trained model with random forest. This is the model. I've read the dataset, checked if there are any null values or not. There are no null values. This is where I trained model with random forest. I've given criterion entropy as a parameter. It can even take Gini, but I've chosen entropy over Gini because entropy is less biased with the features even if it has more number of labels. So I've chosen entropy. And decision random forest is just a group of decision trees, and here the decision trees are built by calculating entropy. So that's the reason I've given criterion entropy. And coming to the extracting memory dump, I've used dump it tool. Like you can extract memory dump by just download the tool and execute this just one line, give the path. Dump it creates memory dump with .ra extension. The memory dump captured using dump it is sent to volatility where the um, features are extracted. It has plugins called Malfind PSXView where which tells the presence of malware. So this is where features are extracted. There are actually 55 features, but I could only extract 44. So these I've put all the features in a bash script. So here actually windows.pslist gives all the list of processes running, but I need only count number of processes running in one of my features. So I did tail plus 5, which means it starts counting from the fifth line, because first four lines gives uh, table headings and all. Like the process list starts from the fifth line, so I started counting from the fifth line. The number gets appended to the features.txt. So likewise, I read all the attributes and I wrote commands. Tools that I used and will be using are PyQt to build GUI, Dumpy to extract memory dump, AWS. In AWS, I've used two services, S3 bucket and EC2 instance. S3 bucket to store files and EC2 instance to analyze. Volatility is a memory framework tool. Machine learning to build my model for prediction. And I've used Bash to automate tasks, and I'll be using Lambda, AWS Lambda as well. This is a proposed flow of implementation that I've thought of working. Actually, to my application, you can give two inputs, memory dump or a malicious sample. For now, I'm focusing only on memory dump. If I complete this, I'll focus on the other part. When you give a memory dump, it gets stored in the S3 bucket, and the train model is also uploaded in the S3 bucket. The files are downloaded into the EC2 instance, and in the EC2 instance, analysis is done and prediction is done. The predicted result is sent to the application, where you can view whether the memory dump, whether there's any malware in the memory dump or not. And this is how my GUI looks, my application GUI looks. There are two buttons, upload and analyze. When you click on upload, you can upload memory dump files. It goes to the S3 bucket. From there, it goes to the EC2 instance. I've done this using AWS command line interface, like where you can download files from S3 bucket to EC2 instance. And from there, you can analyze, memory dump and extract features, predict and give the result to the application. This is all about my project that I've done so far. Thank you.